You can see there is a main scale. Main scale is just like a meter ruler. Main scale is just like a meter ruler. Every single main scale division is 1 millimeter. Every single main scale division is 1 millimeter. Then you can see here there's a smaller scale. This smaller scale is known as a Vernier division or Vernier scale. Here in this Vernier scale, there are 50 Vernier scale divisions. 50 Vernier scale divisions. These are the parts of a Vernier caliper. External jaws. The external jaws are used to take external measurements like external diameter, width, lengths, etc. These are internal jaws. Internal jaws are used to take internal measurements like internal diameters, etc. So you have external jaws, internal jaws. This is known as the main scale. This is known as the main scale, and this is the Vernier scale. You can see this arm is movable. So we call this a movable arm. This is the locking screw. If I lock it, now the arm you can't move. But if I unlock it, then we can move the arm. So before a measurement is taken, at the measurement point, we always lock the locking screw and then take the required measurement. Right. You can see here, this is known as the depth bar. Depth bar. This is used to measure the depth of a cavity. So if I move the external jaws close by, here you can see there is no depth. If I move this a certain distance, the gap here, internal jaws or the inner sides of the external jaws, that distance and that distance both are same, here to here. So this distance here and that distance there both are same. Also this distance here is same. So if I look at this, the distance from here to here and the distance from there to there are same. Also the distance from here to here will be the same, right? So here we have external jaws, internal jaws, movable arm, locking screw, depth bar. This is called the sliding wheel. So this sliding wheel will help the movable arm to travel along the main scale. So we have the main scale, Vernier scale, movable arm, locking screw, sliding wheel, depth bar, internal jaws and external jaws. We can use the external jaws to measure external diameters. Here you can see there is a Sloan pipe cap. To measure the external diameter, place the object between the external jaws, move it until it's tightly fixed. Then we lock the locking screw. Lock the locking screw. Once we lock the locking screw, then we must check the main scale reading, where the Vernier scale 0 is. If you look at this carefully, the Vernier scale 0 is between 46th division and 47th division. 46th division and 47th division. So we take the lower reading, 46. Then we must find out which Vernier scale division is in line with the main scale. Which Vernier scale division is in line with the main scale. Which Vernier scale division is in line with the main scale. So if you look at this carefully, it is either the fourth division. Fourth division is in line with the main scale. So now we know the main scale reading 46 millimeter. We also know the fourth division is in line with the main scale. So how do you find the reading? Reading is equal to main scale reading plus Vernier scale division in line multiplied by the least count. So how do you find the least count? Normally in a Vernier caliper it's already given here. Can you see 0.02 millimeter? It's already given. Or you have 50 Vernier scale divisions. 50 Vernier scale divisions. One main scale division is 1 millimeter. 1 divided by 50, 0.02. So how do you find the least count? Main scale value of one main scale division divided by number of vernier scale divisions. One main scale division is 1 millimeter. Number of vernier scale divisions is 50. 1 divided by 50, 0.02. Or here in a vernier caliper it's already given. So 46 plus fourth division is in line. 4 multiplied by 0.02, that's 0.08. So 46.08 millimeter is your diameter of this echelon cap, echelon end cap. Now remember, some of you all will look at this and say 1, 2, 3, 4, 5, 6. No, no, no. You can see they can number it any way they want. You count the number of divisions. Here you have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 50 vernier scale divisions are there. 50 vernier scale divisions are there. So what do? We place the object between the external jaws, move the mobile arm and lock it. Now the object is not moving. Then what we do is check where the vernier scale 0 is. Where the vernier scale 0 is, it's between two divisions in the main scale. We take the lower reading. Now here it's between 46 and 47, we take 46. Then check which vernier scale division is in line. Fourth vernier scale division is in line. 4 multiplied by the least count plus the main scale will give you the diameter. So external diameter is 46 plus 0.08. 46.08. That is your external diameter of this end cap. Now here we have a metal bob. The metal bob is used in simple pendulum practical. So we need to find the external diameter. So we can place the metal bob like this. Lock it using the locking screw. Right. Now it's locked. Now we need to find the diameter. So how will we find? Check where the vernier scale 0 is. Vernier scale 0 is between the 17th division and the 18th division. Vernier scale 0 is between the 17th division and the 18th division. 17th division and 18th division. So we take the lower one, 17. Check which vernier scale division is in line. So which vernier scale division is in line? Carefully look at it. You keep on moving. Here. 30th vernier scale division or 33rd vernier scale division is in line. So right now, 17 here, 33rd. 33 multiplied by 0.02, 0.66. So 17.66 millimeter, that is the diameter. That is the diameter. Now you can see there is a depth here. There is a depth. We need to find the depth of this cavity. So what do? We place the vernier caliper. Here you go. Such that it touches. Again look. There you go. Then what we do is we lock the locking screw. Now we take the reading. Vernier scale 0 is between 28th and 29th division. So 28. Which vernier scale division is in line? Which vernier scale division is in line? So you travel along the vernier scale, check which vernier scale division is in line. If you look at it, the 40th division is in line. Right? So here 28, 40. 40 multiplied by 0.08. How much? 0.80. So 28.80. That is the depth of this cavity. That is the depth of this cavity. Okay. Again, have a look. We loosen the locking screw. Place it. We move it until it touches the bottom. You can see this touches the open end of the cavity. Touches the open end of the cavity. Right. That means this depth, this is touching the bottom, this is touching the open end. Right. Then we lock the locking screw and we take the reading. So here 20, it's between 28 and 29, 28. Which division is in line? If you carefully look, 40th division. Multiply 28.80 millimeter. That is the depth of the cavity.